project written in Java is now a legacy project. Take a moment to think about this. If you're still writing in Java code and it's not for a legitimate reason, then you're probably going to stay a legacy project. For most people in our industry, moving to Kotlin happened either by force or by love. And no matter the reason, overall developer happiness has shot up. Raise your hand if you already write Kotlin code. Fantastic. So I want you to ask yourselves, am I writing Kotlin in a way that fully utilizes its features? Or have I just substituted Java syntax for Kotlin syntax? If you're wondering whether or not you're writing idiomatic Kotlin, making conversions efficiently, or you're just lost on how to take your large legacy code base and slowly start moving it towards Kotlin, then this talk is for you. Hi, my name is Seetha Annamraju, and today I want to share some of the most common patterns that I see in legacy code in Java and how you can quickly and easily convert them into idiomatic Kotlin to create a more expressive and safe code base. So first, we'll talk about what it means to use idiomatic Kotlin. And then we'll look at common patterns and how to convert those into idiomatic Kotlin. Most of the examples I'm going to use today are loosely based off of real code that I've seen in production in mixed code bases. And last, I'm going to leave you with some of my ideas and suggestions on how to move forward. The basic assumptions for this talk are that 1, you have a basic understanding of Kotlin syntax, and 2, you believe code should be left better than you found it. All right, let's get started. For the purpose of this talk, I'm going to define a legacy codebase as any codebase that started off as a Java project and still contains a substantial amount of Java code. So step 1 is to actually take a step back and take a look at your project. Ask yourself these questions. How much time do I have to invest into this project? What are the priority items? Where is the biggest need? And are there any components that need fixes or updates anyway? This may be a good place to start doing your Kotlin conversions as long as you do it step by step and make sure your entire team is on the same page with you and is able to review and follow your code. Once you decide what you want to work on, you move on to step 2, which is to start converting. And for this, you have 2 options. Option number 1 is to rewrite your entire file from scratch using Kotlin. And this works well when you have a large file where you don't know the logic quite well, or if you're new on the project, or maybe it has many dependencies. So this would also be a good option if you're rewriting an entire feature from scratch, as long as you do it in strategic commits to help your team and be on the same page. Option number 2 is to pull off the band-aid, so to speak. And this is where you would go to the file, click on Code, convert Java file to Kotlin file, and then you're done. Just kidding. But when you do this, the process is fairly straightforward. You're obviously going to end up with some compiler errors, or a lot, and you want to go ahead and fix these first. Next, look at the warnings and suggestions that the IDE gives you and try to fix those. And last, go through the file one last time and look for patterns that you can convert into idiomatic Kotlin. So let the IDE help you on your journey. I keep saying idiomatic Kotlin, so let's talk about that. Step 3. How to ensure idiomatic code. And by idiomatic Kotlin, the main things I like to focus on are null safety, immutability, being concise and expressive, and having easy interoperability with Java. And these are by no means the only idioms in Kotlin, but they are the ones that show up the most frequently in legacy code in Java, and they are the ones we'll focus on today. So let's talk about these in depth. Item number 1, null safety. This is super important because when you are working in the Java world, you probably run into a lot of null pointer exceptions, and some of these may have even caused your apps to crash. Kotlin provides a way to write safe code where you can avoid these null pointer exceptions, so it's important to take advantage of this. And for this, you have 2 main operators. The first is the safe call operator, or the question mark, and the second is the non-null assertion operator, or the double bang, or the 2 exclamation marks. The safe call operator says, maybe this variable is null, and the double bang says, this variable is definitely not null. So whenever you do a conversion from Java to Kotlin in the IDE, you usually end up with code that looks like this. Here I'm emphasizing all the double bangs. We want to try to get rid of these. And the reason we want to get rid of them is because they offer no protection against null. You're basically yelling at the compiler and saying, this variable will never be null, but when it is null and you're inevitably wrong, you're probably creating places where your app is going to crash. And what's worse is that you've taken your Java null pointer exception and turned it into a Kotlin null pointer exception. So please don't do this. Instead, let's work to get rid of these. The basic thinking here is if the variable is not supposed to be null, then make sure you define it to begin with. And if it can be null, make sure that you handle all the cases where it is null. Let's look through some scenarios to help get rid of these. The first option is to use the safe call operator. And the safe call operator basically says, execute this if the variable is not null. So in this case, if I have a media player (stop), I'm saying stop if media player is not null. The Elvis operator is an often underused operator, but it can be super valuable when you have a default value or a default path. In this case, it takes two expressions and it returns the first expression if it's not null. Otherwise, it returns the second expression. In this case, if name.toString is not null, it returns it. Otherwise, it returns unknown and assigns it back to result. You can also consider using a late init_var. Late init_var literally stands for a late initialization of a variable, and it does just that. Whenever you have a case where you need to initialize use a variable and you know it will get initialized before it gets used, but just not right away, this may be a good option. It's often used for things like dependency injection or if your variable is closely tied to lifecycle methods. But late init_var is by definition a variable, and therefore offers less predictability in code. This brings me to my next point. Item number 2, immutability. Immutability basically says, when you define a variable, you can be rest assured that it won't change by the time you use it. This is important because it offers more predictability and repeatability in your code, and it also reduces the number of states that your application can get into. This is somewhat easy to do in Kotlin, but it does require a new way of thinking if you come from the Java world. You can consider using bylazy. And bylazy is the immutable way to late initialize something. So in this case, let's say I have a Java object, media loader, and I want to initialize it at some point later on by passing in context. The way you would do this using bylazy is to put inside of the lazy block, and media loader would basically get initialized whenever context does become available. Whenever possible, I would say try to use bylazy in place of late init_var so you can take advantage of immutability. You can also do a local capture of values. And let's say you have a variable, say media player, which needs to be declared nullable. And in this case, my IDE, when I do the conversion, is going to go, well, media player is a mutable object, so every time I use it, I'm going to throw in these double bangs. So this looks bad, and we want to get rid of them. One way is to do a local capture of media player in something like val player and any other objects, and do one null check and use it inside. And by doing this one null check, you've taken something that is mutable and nullable and converted it into something that's immutable and non-nullable, at least within this scope. And you've also created more predictability in your code. And what's great is your code's also much cleaner. Okay, you're probably starting to see how you can say more with less when it comes to writing Kotlin. Let's now look at a few more examples to really understand why this is important. Item number 3 is about being more concise and expressive, especially by using Kotlin standard library. Over 70% of your time is spent reading code rather than writing code. I don't actually remember who said this. Maybe I said it. But if you really think about it, you know it's true, especially when you work in legacy code or if you're new on the team. So the faster and easier it is for us to read code, the more productive we'll be as developers. And that's great because we can go home. So here's a surprisingly common Java if construction, where you drill deeper and deeper until something very specific is not null, and then you do something about it. When you start writing Kotlin code, you realize how crazy this is. And the reason it's crazy is because each line is basically repeating the same exact null check. Some Java developers will throw this inside of a try-catch and forget about it. And this is fine, but most of the time you don't actually do anything with the exception. So consider using Kotlin's let. Let basically says, do everything inside of this block as long as everything to the left is not null. So whenever you find yourself staring at extremely verbose and repetitive code in Java, consider using one of standard library functions like let or anything else that's out there. You can consider using apply if you need to do a configuration of an object or if you have a mutable variable that you need to initialize, but it's immediately followed by a null check in order to set some methods on it. This would be a good place to use apply. Here, I have a media player object that I've initialized. And inside of the apply, I'm setting a data source, setting a listener on it, and so on. With is very similar to apply, but the way I like to think of with is with some object, do something else. So in this case, I have with syllabus, return a course object. Pretty simple, right? Whenever you find yourself transforming collections in Java using a bunch of for loops, ask yourself if you can use maps and filters in Kotlin. Let's say you have a list of students and you want to convert that into a list of student view items for the UI. And let's say you also want to filter it by major. The way you would do this in Kotlin is to take the student list. You would create an association between the major and a student view item that you've just created. Then add in the filter, computer science, and then map it all back into a list of student view items. See how simple this is and readable. You create less errors by writing code that's easy and concise to read. And what's great is that in Java, you would have mutated data inside of a collection, whereas here, you've created a brand new immutable collection, which takes advantage of immutability. Item number 4 is easy interoperability with Java. There's some really easy things you can do to increase your Kotlin code coverage, and at the same time, make sure that your Java side isn't affected in a negative way. One of these is to annotate your Java APIs, especially using annotations like @nonnull and @nullable. Whenever you have a field coming from the Java side, ask yourself if it's meant to be null or not. Let me tell you why this is important. The Android SDK is littered with fields that are not yet annotated, and this sometimes causes our apps to crash or behave in unexpected ways. So it's really important to be careful about this, even as the Android SDK is being refactored. So similarly, in your code, whenever you have a field coming from Java, as a rule of thumb, ask yourself, are you really sure that this variable can never be null? One of the biggest advertisements for Kotlin is when you can see a Java object that looks like this, and you can convert it into something beautiful like this in Kotlin. What's great about this is that you've created something more concise, and it also forces you to double check whether any of your fields really need to be nullable. So whenever you have Java objects, consider using something like a data class. You can also write extension functions for any of your utility classes. Let's say in Java, you have something called extra string utils, which contains a method to opposite case. It'll take a string, convert the lowercase letters to uppercase, and vice versa. So this is a static method in here. What you can do is create an extension function on string with this method. And in fact, you can create a file called string.ext.kt and put in all of your string extension methods here, functions here. And if you need to use this on the Java side, just put in the annotation @file::JVM name and pass in the name of the file that it used to be. And if you have multiple functions in this file, just use the annotation @JVM multifile class. Okay, so we talked a lot about idioms, but what are some common questions that come up during this process? The first is, how do I do a large refactoring into Kotlin? The best way is to focus on small pieces at a time or small features at a time. But most importantly, to do strategic commits. The first commit could be to take the file, convert it into Kotlin using the IDE. Next, you're probably going to end up with compiler errors, so fix those as your second commit. And make sure that your code is working fine. And then commit number 3 could be to fix all the warnings and suggestions that come up in your IDE, and you're slowly starting to move towards idiomatic Kotlin. And last, make sure you do a last walkthrough and look for patterns that we talked about or any other patterns to convert into idiomatic Kotlin. So how do I ensure idiomatic code? Well, the best way is to do it through code reviews and learning from each other on your team. You can look for areas to apply things like null safety, interoperability, immutability, and conciseness. But you can also go on kotlinlang.org and look at the list of idioms that you can get started with. So what's next? I've only touched the surface of what it means to use idiomatic Kotlin. I've covered things that show up most frequently in legacy code in Java, but there's tons more. You can consider using lambdas for simplifying your code further, or maybe sealed classes to represent different states, or explore some of the many standard library functions that are available to you. So far, we talked about taking a step back and taking a look at your project. Look for areas to apply things like null safety, immutability, interoperability, and better readability. Most importantly, though, make sure you keep your entire team on the same page. It's more important to have a solid code base and a solid team than to move to Kotlin on day one. So, what challenges do you face in your teams and in your legacy code bases? I would love to chat with you after this. Thank you.